A boy riding on his bike is going toward the east at a speed of 4√2 meter per second. At a certain point, he produces a sound pulse of frequency 1650 Hz that travels in air at a speed of 334 meter per second. A second boy stands on the ground 45 degrees south of east from him. Find the frequency of the pulse as he received by the second boy. Fine. Now let's say this is the first boy who is traveling east, right, with a speed given by 4√2 meter per second, and there is a boy standing at a 45 degree south of east. This is my south, this is my east, so 45 degrees south of east, this is my 45 south of east. So a boy is standing over here, right, he is the observer, this is my source. Fine. Now I have to calculate the frequency as heard by the observer. Now what I'll do is I'll take the component of the velocity of the source in two directions, that is one along the observer and another is perpendicular to the observer. Fine. So the velocity that is in the direction of observer will be equal to 4√2 cos of 45, and this will be 4√2 sine of 45. Now one thing is that 4√2 sine of 45, this velocity is in the direction perpendicular to the observer, so it won't create any difference. Fine. So the frequency heard due to that one will be the same, but there will be a frequency change due to the 4√2 cos of 45 because it is in the direction of observer. So in such case, this is my source approaching the observer directly, so the frequency heard by observer will be given by V divided by V minus Vs into frequency f0, where the velocity of the source is 4√2 cos of 45, so it will be 334 divided by 334 minus 4√2 cos of 45, that is 1/√2, into f0, that is 1650. So it comes out to be 334 minus 4 into 1650, that is 334 by 330 into 1650. On solving this equation, I get the frequency as 1670 Hz. That is the answer.